Okay, last review before we're done with this unit. Okay, lesson J9, we're talking about geometric probability. So what this really means is the probability that an event is to occur. If you remember probability from middle school, you're looking for the how many outcomes are possible and what the situation is you're looking for. So the number of ideal out of the number of possible outcomes. So what that means is basically the following. If a point is chosen randomly on EH, find the probability of each event. So what is the probability that the point is on FH? Well, first of all, the total number of outcomes. Let's start there. If I'm looking at this entire number line, if a point is chosen at random anywhere between E and H, that means that there are, let's say this is all measured in inches, that means there's 5, 6, 7, 8 total inches that we could possibly land on, okay? Out of that 8-inch length, if I want it to land on FH, the ideal space that I want it to land within is worth 3 inches. So the probability that it will land within FH on this line is 3 out of 8. I can give probability a couple of different ways. We can either represent probability as a fraction, which in this case would be 3/8. That doesn't reduce at all. If I do 3 divided by 8 in the calculator, I see that that's equivalent to 0.375. That's also equivalent to a percent of 37.5%. All 3 of these ways are good ways to represent probability. Any one of those 3 is satisfactory for an answer. You do not have to give all 3. The question didn't specify how to present the probability, but all 3 are good. When it comes to probability, as another side note, a probability of 0 means that it's impossible for something to happen, as opposed to a probability of 1, which means it's guaranteed for something to happen, right? A 1/2 probability means it has a 50-50 shot. There's a 50% chance of something happening. So the closer your number is to 0, the less of a chance it is. The closer it is to 1, the more of a chance it is. In terms of percent, that's difference between 0% and 100%, right? No chance versus a guaranteed chance. Okay, so this first one had a probability roughly of around here. Hopefully that makes sense. Okay, number 2. What is the probability that the point is not on EF? Well, if EF is worth 5 out of 8, that means the probability that it's not on EF is going to be 3 out of 8. Just like the answer on number 1 was, it just happens to be the same. So again, my answer could be represented as 3 over 8, or 0.375, or 37.5%. Number 3, what is the probability that the point is on EF or GH? So we want the probability that it's on EF or GH. So that means it has a probability of being on any of those 7, let's say, inch spaces out of the full 8 inches. So we can represent this result as 7/8, which does not reduce at all, which is also equivalent to 0.875, which is also equivalent to 87.5%. What is the probability that the point is on EG? Well, EG is worth 6 out of 8, which does actually reduce. So I would say that this has a 3/4 possibility, which is the same as 0.75, which is the same as 75%. Oops. Okay, number 5. find the probability that a point chosen at random inside the rectangle is in the specified shape. So what is the probability that if I were to pick a point anywhere within this rectangle, it would actually be within the square? So what we're saying is that the entire space, so my total number of outcomes in a sense, the total space that we can work with is my rectangle. But we're saying, what's the probability that it lands within the square? Okay. So in this rectangle, the total space that the rectangle takes up is its area. And the area is base times height. So that means my rectangle is taking up a 7 by 4 space. So that's a 28 square inch space. The square inside of the rectangle takes up a 2 by 2 space. I know that because if it's a square, it means all the sides are congruent. So that means it has a 4 square inch space. So the probability that it's going to land within the 4 square inch space out of this whole 28 square inch space is, if I reduce that fraction, it's going to be a 1/7 possibility, which is equivalent to 0.1428571429, but it does say to round to the nearest hundredth, which is the second spot. So 1428 rounds to 0.14. While that is my final answer, just to clarify, that is also equivalent to a percent of approximately 14.3%, because it was 0.1428. So that 2 rounded to a 3, okay? But this is the answer version that they were looking for based on the instruction. Question B. Within this rectangular space, what is the probability that it actually lands within the triangle? So this space, this rectangular space, is 14 by 13. So that means my rectangular space gives me an area of 182 square centimeters. But the question is, what's the probability that it lands within the triangle? So the triangle base times height divide by 2 is 5 times 12 divide by 2. I get a triangle area of 30 squared centimeters. And they are, again, asking rounded to the nearest hundredth. So while this is equivalent to 15 over 91, remember math, enter, enter on your TI calculators simplifies a fraction for you. 15 over 91, that is equivalent to 0.1648. So that's to the nearest hundredth is 0.16. Since it was 0.1648, that's equivalent to approximately 16.5%. But again, this is the answer that they were looking for. Hopefully we're good there. Question C. If I'm looking for the probability that a point selected at random within this rectangle actually lands within the circle, I need both areas again. The area of the rectangle is base times height. So 16 times 22 gives me an area of 352 squared millimeters. The area for my circle is pi r squared. So pi times 8 squared is 64 pi millimeters squared. And if I take 64 pi, and I divide by the 352, to the nearest hundredth, I get approximately 0.57. So that's technically 0.571198, etc. So that's 0.57 to the nearest hundredth. Question D, the regular pentagon. We have our regular polygon again. We have to use that area equals 1/2 times the apothem times the perimeter. I know how much we all hate that formula, but process doesn't change. Out of this entire rectangle, what is the probability that it lands within the pentagon? Okay, so the area of the whole entire rectangle, that's a 10-foot by 8-foot space. So I know that that's going to be out of 80 feet squared. So out of those 80 feet squared, we want to know the preferred space. What is the area of the polygon, the pentagon here? So we need to know the apothem and we need to know the perimeter. Well, if one side is worth 4 and there are 5 sides, I know my perimeter is 20. But now we have to do that side work that we did in the last lesson or 2 lessons ago to find the apothem, right? If I think about the apothem as being from the center to the middle of the side in a perpendicular direction, we have to split this into a central angle. And I know the measure of the entire central angle because if a full circle is 360, and I can see that this is being divided into 5, I know each entire central angle is 72, which means if I focused on one side of this triangle here, I can find my apothem using half of that 72 angle, which is 36 degrees. The only reason why I can do this is because if one whole side is 4 and my apothem splits that in half, I know this portion is 2. Okay, hopefully we're good there. So I do my trigonometry. I know it's tangent of 36 because I know the side opposite from 36 and I want the side adjacent. So tangent of 36 is equal to opposite 2 over adjacent A. Once I do my cross multiplication, I end up having to do 2 divided by tangent of 36. And that tells me that my apothem is approximately 2.753. So once I do that area, 2.753 times 20 times a half, I get an area of approximately 27.53 feet squared. When I divide that by 80, I get that my area to the nearest, my probability to the nearest hundredth is going to be 0.34. Let me know if you have questions. You can see the rest of this sheet on the next video.